Hello, my dear students. Once again, welcome back for the continuation of chapter 6, that is hydrogen in chemistry. Today, I would like to explain you preparation of hydrogen gas from water, dilute acid, and alkalis. Before I begin this, I would like to explain you activity series of metals. Now, what is activity series of metals? Activity series of metals is a list of metals which are arranged in the decreasing order of their reactivity. Potassium is the highly reactive metal, so it is placed at the top of the series, and gold is the least reactive metal, so it is placed at the bottom of the series. And hydrogen is the only non-metal which is placed in the activity series of metals, because hydrogen can form cation by the loss of its valence electron. Potassium, sodium and calcium, these three metals, they react with cold water. The reaction of potassium and sodium with cold water is highly exothermic, whereas the reaction of calcium with cold water is less boiling. Now, magnesium reacts with boiling water. Below magnesium, like aluminium, zinc, iron, etc., they react with steam. The metals which are below hydrogen in the activity series, like copper, mercury, silver, gold, they do not react with water at all. Let's begin the preparation of hydrogen gas from water. As I told you, the reaction of potassium with cold water is highly exothermic. When potassium is added to a trough containing cold water, a large amount of heat is evolved. Hydrogen gas bonds with a pop sound. Next, when sodium is added to the trough containing cold water, sodium being lighter than water, it floats on the surface of the water and darts about freely on the surface of the water and finally bursts into a golden yellow flame which burns with a pop sound. Next, calcium, when it is added to a trough containing cold water, calcium being heavier than cold water, it will sink. And effervescence takes place with the evolution of hydrogen gas. A cloudy liquid is formed, that is calcium hydroxide. Now magnesium, it reacts with boiling water. So hydrogen gas is evolved and magnesium oxide is formed. Now next, aluminium, zinc and iron, when these metals are heated, these metals, they react with steam. Now when steam is passed with the heated iron, hydrogen gas is evolved and a magnetic oxide is formed, that is triferric tetraoxide, and this is a reversible reaction. Your double arrow represents the reversible reaction. Reversible reaction means is a chemical reaction in which we can get back the original substances. Now next, preparation of hydrogen gas from dilute acid. As I told you here, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead. These are the metals which are above hydrogen in the activity series. Here all these metals except lead, whenever they react with dilute acid, they displace hydrogen from the dilute acid. But these metals, potassium, sodium, these metals we cannot use for the preparation of hydrogen gas from dilute acid because their reaction is uncontrollable. Calcium is not used because it is an expensive metal. So below calcium we can use magnesium, aluminium, zinc, iron, etc. So we'll take zinc. Zinc, when it reacts with dilute sulfuric acid, as you know that zinc is above hydrogen in the activity series. So zinc displaces this hydrogen from dilute sulfuric acid. So hydrogen gas is evolved. zinc itself combines with sulfate, zinc sulfate. If you use dilute hydrochloric acid here instead of dilute sulfuric acid, here you will get zinc chloride. And if you use iron instead of zinc, you'll get here ferrous sulfate. And next, here lead is not used for the preparation of hydrogen gas because it forms an insoluble lead chloride or lead sulfate which gets deposited on the surface of the metal. Further, it stops the reaction. Next, here for the preparation of hydrogen gas from dilute acid, we cannot use dilute nitric acid because dilute nitric acid being a powerful oxidizing agent, it oxidizes hydrogen to water molecule. Now next, below hydrogen like copper, mercury, silver, gold, these metals, they do not displace hydrogen from dilute acid. Now next, for the preparation of hydrogen gas from alkalis. Here, lead, zinc, aluminum, these are amphoteric metals. Amphoteric metals are those metals that they react with acid as well as alkalis. So here, I am taking zinc. Zinc is amphoteric in nature. Sodium hydroxide is an alkali. When this zinc reacts with sodium hydroxide, which is an alkali, we'll get hydrogen gas and a complex salt is formed, that is sodium zincate. When aluminium is heated with or concentrated sodium hydroxide solution, we'll get hydrogen gas and sodium aluminate. Dear children, here we come to the end of today's online class. Please go through this video clip. This will help you to understand the lesson. Thank you very much.